Hello all, this is Trusha Patel. Welcome to part 5 of microprocessor. Let us talk about design of macro preprocessor for the assembly language. As we know that the macro preprocessor will take the assembly program with macro definitions and the macro call, and it will generate the assembly program where the macro definition and the macro calls are eliminated and all macro calls have been replaced with the macro body. Now, the design overview of the macro preprocessor. The tasks involved in the macro expansion are identifying the macro call in the program, then determine the value of the formal parameter, then maintain the value of expansion time variable declared in the macro, then organize the expansion time control flow, and determine the value of sequential symbols. Next is the perform expansion of the model statement. Now for all this, four-step procedure is followed to arrive at the design specification. The first is identify the information necessary to perform a task. Second, design a suitable data structure to record the information. Third is determine the processing necessary to obtain the information. And fourth, determine the processing necessary to perform the task. These four steps are similar for all the language processors. Now, starting with the first, that is identifying the macro call in the program. For that, we have to maintain one table, that is MNT, macro name table, which will hold the name of the macro definition in the program. When the macro definition is processed, the macro name is inserted inside the table. While processing a statement, preprocessor compare the string found in the mnemonic field with the names available in the MNT, and if it is matched, it will indicate that it's a macro call. Second, to determine the value of the formal parameter, we need a table that is APT, actual parameter table, which will hold all the formal parameters. And the entry in APT is a pair, that is formal parameter name along with the value. The next step is maintain the value for the expansion time variables. For that, we need a table that is EVT, expansion time variable table, which will hold the value of all expansion time variables. Again, the entry in EVT is a pair, that is a name of environment variable and the value. The next is organize expansion time control flow. We need to maintain MDT, that is macro definition table, which will store the entire body of the macro. The next is determine the value of the sequencing symbol. The table required is SST, that is sequencing symbol table, which hold the sequencing symbols, and each entry is a pair, that is sequencing symbol name and the entry number in MDT, that is macro definition table. Now the SS entry is done when encounter a statement which contain the sequencing symbol in its the label field if we are addressing the back references. And another case is a forward referencing. In that case, whenever the SS is encountered as a reference, the entry will be done inside the SST. The last is perform the expansion of the model statement. For that, we have to maintain one counter, that is MEC, macro expansion counter, which will point to the MDT, that is macro definition table entry containing all the model statement, and the counter consecutively increment or decrement to fetch the new instruction from the MDT. To get the values for the formal parameter, we need to access the APT. To get the values of the expansion time variable, we have to access the EVT. And to get the values of the sequencing symbol need to access the SST. Now, these all are the data structures which are used in the macro preprocessor. First is MNT, that is macro name table, which consisting of the macro name, then number of the positional parameters, number of the keyword parameters, number of the expansion time variables, then MDT pointer, that is pointer to the very first location of the macro definition table, then KPD tab pointer, that is the pointer to the very first entry of the KPD tab, and likewise we have a pointer for the SS tab. Now PN tab is a parameter name table which consisting of parameter names. Then next is the EVN tab, which is containing the expansion time variable name, and SSN tab consisting of the sequential symbol names, then KPD tab containing the parameter names but they are the default values. Then MDT, that is the macro definition table consisting of the label, opcode and the operands. AP tab, that is actual parameter table containing the values of the actual parameters. Then EV tab, that is expansion time variable table containing the values of the expansion time variable, and the SS tab, that is the sequencing symbol table consisting of the number of entry in the MDT for that particular sequencing symbol. Now looking at how the macro definition are processed. So let's say for example we have this macro called clear MEM. We have this all data structures which we have discussed earlier. So start processing from the very first statement after the macro, that is the macro prototype. In that, this clear MEM is a name of the macro. So that is need to be entered in the MEN in the very first entry, that is clear MEM. Then we have three formal parameters, that is X, N and REG. They are now apart from that three, X and N are the positional parameter and AREG are the keyword parameter. So the count for the positional parameter is 2 and the keyword parameter is 1. Now this all three parameter will be entered inside the PN tab, and 1 is my keyword parameter. So in KPD tab we have to enter the name of the parameter, that is REG, and the default value, that is AREG. Now here 10 is some memory location because this all tables are available inside the memory at some allocated memories. Now next statement is LCL and %m. Now here m is the local expansion time variable. So name of that expansion time variable is entered inside the EVN tab, and the code generated for that will be LCL. The mnemonic will remain as it is, and instead of name of the expansion time variable, we will put the entry like that is expansion time variable, so E, and that is available at the first index in the EVN tab. That's why the index is 1, right? And here 25 is again some memory location where the MDT is located inside the memory. Now next instruction is and %m set 0. So the code generated will be E comma 1 because m is available at the first index in the EVN tab. Then set mnemonic will remain as it is, and 0 is a constant that will remain as it is. Now next instruction is move R and %reg equals to 0. Now the code generated will be move R. Now reg is the third parameter, that's why it is written parameter, so it is p and available at the third index 1, 2 and 3. That's why here index identified is 3 and this equals to 0 is the literal which will remain as it is. The next statement is dot more, then move m and %reg, comma and %x plus and %m. So here more is a sequencing symbol. So the entry of more will be done in the SSN tab. The code generated will be move m. Now first is and %arg. That's why it is p3 because the parameter is available in the third index, comma and %x plus and %m. So and %x is available at the first index in the parameter table and m is the available in the first index in the expansion time variable table. So p of 1 plus e of 1, right? Okay. Now this more is available at index number 28. So that's why this 28 is entered in the SS tab, right? And here this 5 is again some memory location where this SS tab is actually located inside the memory. Now next statement is %set %m plus 1. So the code generated will be environment expansion variable 1 set expansion variable 1 plus 1. The next statement is AIF %f any capital N dot more. So AIF instead of m we will write e comma 1, then not equals to condition will remain as it is. Now here n is the parameter which is available at the second index, that's why it is written p comma 2, and more is a sequencing symbol and it is available at the index number 1 in the SSN tab, that's why it is written s comma 1. And the last statement is m end, so the last generated code will be the m end. Now here in the MNT table, we have to write down the number of expansion time variable we have encountered. So here we have encountered only one expansion time variable, that is m. That's why the count is 1. The next is pointer to the MDT, that is the very first memory location from where we have started the entry inside the MDT. So that is 25. The next is pointer to the KPD tab. So the memory location where we have done the first entry in the KPD tab, that is memory location 10. And the third is the SSTT, that is pointer to the SS tab. So SS tab is available at the memory location 5, that will be entered over here. So this is how the macro definition is processed by the macro preprocessor. Next, start with how the macro preprocessor will perform the macro expansion. So, this is the entry which we have already done when the macro preprocessor have processed the macro definition. Now, let's say in my program I have one macro call, that is clear MEM AREA, 3. So this AREA will be the first actual parameter, then 3 is my second actual parameter, and we are not having the third parameter. So for third parameter, I already have one default value, that is AREG. So that AREG will be copied in the third parameter in the actual parameter table. Now it will start expansion. So it will initialize the MEC, that is macro expansion counter, with the value of MDTP. So MDTP we can fetch from the MNT, and that is 25. So MEC is initialized with 25, that means it is pointing to the memory location 25, right? Now at memory location 25 we have an instruction LCL, environment time variable 1. So that one variable we already used. Then the program counter is incremented by 1 and pointing to the memory location 26. Now here it is written that for the expansion time variable 1, set the value 0. So in the EV tab, 0 value is assigned, which is for expansion time variable M. Now again MEC is pointing to next location, that is 27. Now here it is written move R parameter 3 equals to literal 0. So the first statement will be inserted inside the in place of the macro call, that is move R. Now parameter 3. Now this parameter 3, now we have to fetch from the actual parameter. So in the actual parameter, the third is the AREG. So here it will place AREG, and this equals to 0 literal will remain as it is. Now next MEC will be incremented by 1, and instruction is move M parameter 3 comma parameter 1 plus expansion time variable 1. So it will write something like move M parameter 3, that is AREG, equals to parameter 1, that is area. Okay, here it should be area plus the value of the expansion time variable 1, that is 0 over here. Now next instruction is set expansion time variable plus 1. So the value of M will be incremented by 1 and it will become 1. Now next statement is AIF expansion time variable not equals to parameter 2. Then we have to go to sequencing symbol 1. Now here the value of the expansion time variable 1 is 1 and the parameter number 2 is 3. So the condition is true, 1 is not equals to 3. In that case we have to go to the sequencing symbol 1. Now here sequencing symbol 1 is available at the memory location 28. That means MEC is pointing to the next memory location, that is 28 instead of 31. Now again the code generated will be move M parameter 3 comma parameter 1 plus expansion time variable 1. So it will become move M AREG comma area plus 1, because right now the value of expansion time variable is 1. Again it will increment the value of the expansion time variable by 1 and it will become 2. Again check the condition that whether the value of expansion time variable is not equals to the second parameter. Yes, 2 is not equals to 3 over here. So it will jump to the sequencing symbol. So again MEC is go to the 28th memory location. Again it will generate a code that is move M AREG comma area plus 2. Then go to next. Then value of the expansion time variable is incremented by 3. Then again check the condition, is the value of the expansion time variable is not equals to the second parameter. No, now the condition is false. So it will go to the next statement, that is macro end statement, and it will end with the macro expansion. Thank you. We'll be back with part 6 of macroprocessors.